Okay. Hi, my name is Doug Plata. I'm a physician. I'm trained in family and preventive medicine, and I work in urgent care and occupational medicine. I am definitely a space advocate. It's my passion. It's sort of an intellectual hobby. It's not my line of work, as I think for most of you, that's the case. So I have started the Space Development Network. This is a free-to-join space advocacy organization, and we are projects-oriented, and we organize people into working groups. When you join, you list your interest, and then we gather to get people together accordingly, and with projects and demos as the focus of what we hope to contribute to moving the ball forward in many different ways. And so there's the website developspace.info. You can go and visit it. It's very extensive. I think you'll have many hours of enjoyment looking through it, all the different aspects of space development and settlement. So this is the Green Hab concept. In the last hour's presentation, I described the InstaBase concept, the inflatable InstaBase, and there were these two Green Habs, which are obviously the greenhouses as part of the InstaBase. So what I'm going to do is I'm going to explain what part it plays in the InstaBase, and then how the Green Habs would meet the nutritional needs of the initial permanent crew. And specifically the work of our agriculture working group, which is one of our working groups within the Space Development Network. And this group specifically designed the Green Habs. And then the main part of this presentation is going to be going through the choices that we made. There's a lot of options. We try to be comprehensive in considering all the options. And then we chose specific choices. It's very interesting comparing the Moon and Mars in terms of what fits best in each situation. I will mention the role of robots, as well as the role of harvest processing machines, and even storage. And then the food working group is actually a separate group dealing more with things like culinary arts and cooking and how that's done. And how we work backwards from nutrition all the way back to the nutritional needs, all the way back to the planting schedule. And then I'll mention special meals and the Martian Cookbook that we'd like for somebody to go ahead and develop. And also mention about food processing machines and how important that is for saving time. So if you're coming here without having been in my previous presentation, let me just summarize the last half hour, and that is the InstaBase. The InstaBase could work on the Moon. It also work on Mars. The reason why it's instant is because it's completely inflatable, and you open a valve of condensed air, and within probably less than half an hour, the whole base will be constructed. And it's composed of different modules. You see the Green Hab modules there. I'm actually just now finishing up construction of the plastic version of that, sheet plastic. For about $1,500 in materials, we're actually constructing this mock-up of it, and it's so large it barely fits into a high school gymnasium. Here's the different aspects of it, and we are going to be focusing on those two Green Habs. And so let's talk about the size of the Green Habs. We size it to meet the nutritional needs of an initial permanent crew. So here you have the footprint is 288 meters squared, or 3,098 feet squared. That's 35% above the average US home footprint. So these things are large, and that's added together. And then the volume you see, and the reason I emphasize volume is because you need a lot of plants to be able to supply the nutritional need of a crew of 8. And so you're going to need not only a large surface area, but a large volume in working, growing things in 3 dimensions. So the Agriculture Working Group is part of the Space Development Network. I started this organization, and as people join, they get organized into different working groups to try to move things forward. And many different working groups, but like the Habitat Working Group, Agriculture, and the working groups, but there's more. And then each working group is working on the plan for sustainable space development. So this is not a society. We're not getting together to talk about all sorts of ideas. Instead, we have a very specific plan, and then we figure out the details of it, and then figure out what demo projects can we do. For example, can we do a tabletop demonstration of a hydroponic little greenhouse that grows at least one item of each category of food, you know, one potato, one tomato, one strawberry, etc., one protein. And so we want to not just talk forever, we want to actually do things and try to move the ball forward to achieve actual results. Here, for example, is the agriculture working group, and we've met probably 12 to 15 times. Different people sort of come and go. And what we have done is we've set up a number of databases that we all, you know, Google spreadsheets, sort of things that we all can work simultaneously on, both data as well as descriptions or write-ups. And it's not just for the agriculture working group, but we have quite a number of databases for various groups. But within the agriculture working group, we do have this file, which is, you know, a fairly comprehensive listing of the different food items or the different plants, and, you know, how many kilocalories per gram, you know, how much light that they need, how much water they need, and trying to you know, pull together this information to help us understand what are the needs, you know, how much irrigation do we need, how much fertilizer, and these sorts of things. How much waste, because waste processing is part of the picture. So the design choices, you know, this is interesting, and I can't say that we have the final word on this. This is just what we've come up with at the present time. You all, you know, some of you may have definite ideas about how to do it different. I'd be interested in engaging in that conversation with you. But what about shielding? Should there be shielding or not? Fascinating question. If there is shielding, should it be regolith or water? And then lighting, should it be transparent, so sun does the lighting? Or should it be solar panels with LEDs? Or should it be light tubes and fibers? We looked at hydroponic versus soil versus hybrid, and I'll explain what that last term means. What about aquaponics? How about growing fish? What about various types of meats? We looked at these issues and discussed it, and then made decisions to design the green hab. So let's jump into it. And this is really getting into the heart of this presentation. What about the shielding? This is not, it's actually not an easy decision. We are not stuck on the idea that the greenhouse has to serve both the moon and Mars. In particular, and Dr. Zubrin points this out, Mars has a limited atmosphere, but it is supposedly enough to be able to stop the solar particle events, not so much the GCRs, but the solar particle events, to keep the plants from just being killed, from their DNA being decimated. So that is great, and it means that you can take advantage of the sunlight without having to ship so many solar panels. The problem with that is that if you have people walking around spending hours a day within that unshielded green hab, then they're going to be accumulating radiation thanks largely to the GCRs, the galactic cosmic rays. And so that's problematic, and so we're trying to figure out what to do. Now, on the moon, it's really quite simple. It has no atmosphere. Solar particle events will kill the plants, kill the people. It needs to have shielding. The only question is what type of shielding, okay? So what we decided is that the moon definitely needs shielding on the green hab. For on Mars, as I mentioned, you have these various factors. You can look at issues of, okay, can you have people go in briefly and bring out trays and work on them in a shielded setting? Can you have telerobots come or some sort of gantry system, you know, I'm not sure if gantry is the right term, but, you know, where you have arms coming down or on wires and picking it up and carrying a tray to a shielded area. So there's different possibilities. So it gets complex. I mentioned about the atmospheric shielding. You do have an issue of two-dimensional growth if you're growing using sunlight versus 3D, in which you have the efficiency of you have less mass if you can grow in 3D, less mass for the greenhouse. For the humans in the greenhouse, there is the issue of GCR exposure. Question is, can you remove the trays? You can remove the trays, but what about the pumps systems? Are those going to be with the trays? Probably would need to be. And then what about telerobots? If you have telerobots, then you're basically consuming crew time, which is not recommended. So as we went back and said, okay, the moon is fairly clear what's needed, but for Mars, after discussing it, our decision was that a Mars greenhouse probably needs to have shielding. Even if it's water shielding, we can see through the water, but infrared can be attenuated by the water, and so it's the equivalent of having shielding, blocking out the sunlight. So what we decided is that on the moon, water is more challenging to get than just pushing up the regolith. But on Mars, actually, if you site it on a location where there's a glacier underneath you, then actually getting the water and pouring it in between the layers might actually be the somewhat easier thing to do than regolith. So that's perhaps arguable, but that's where we came down on that issue. For the lighting, if we do have shielding, we got these choices of direct sunlight, but you can't have the shielding, or the photovoltaic with wires and LEDs, very optimized, or solar concentrators are another possibility with fiber optics. We went, let me explain to you. Some may be concerned that having to ship photovoltaic or PV cells or panels might just weigh too much. It's just not practical. You need the direct sunlight. As according to our calculations, a 100-ton Starship would be able to deliver enough solar panels if everything's optimized to feed the caloric needs of about 300 residents. And so that strikes us as something that is doable, within the range of doable. So between these three, we chose the PV panels with wires in magenta LEDs. And we chose not the solar concentrators because the support structures are greater than photovoltaic cells. Now, hydroponic versus soil, again, a fascinating issue. Hydroponics can be very, very efficient, sort of high density sort of things. But soil is more natural, sort of easier to grow with the microbes loving to live in the soil. But actually but then soil gets into issues of contaminants, both on the moon and Mars. There's health issues. But what you can do is you can take rocks and clean them, and then you send them through a rock grinder, and you can make granular material, and that is sufficient to be able to have a place for roots to settle and create the symbiotic relationship with bacteria and fungi. And so actually what we decided was actually to do a hybrid of the two. And that is where you have this granular material that makes it easy for in the plants less fragile to grow in, but you're running nutrient solution through this granular substrate. And so that's what we came down to in making our decision. Aquaponics, this is a plants with fish, and our feeling was the amount of work that it would take from the crew to maintain the system is more than what we would want to do. So actually we decided to not do aquaponics. Let me be clear. We were talking about the initial permanent crew. So this is a pretty limited crew. This would change. A lot of these issues would change as the population grew larger and you had specialization and economies of scale. Okay, what about things like chickens? We're getting into the meat issue. Chickens, you know, they make these delicious little protein nuggets. We felt that the dealing with the odors and the cleaning up after them is going to be taking too much crew time. And so for the initial permanent crew, we decided to not go with chickens, but chickens would be in the picture probably in the international Mars exploration phase, as you start having specialty habs that are dedicated to farm sort of situations. Okay, what about insects? Insects can do a very efficient job in taking plant waste and converting them into edible protein. So it sounds like a winner. So should we include insects as a part of the diet for the initial crew? What do you guys think? Did we choose to go for it? No, and here's the reason why. Yes, nutritionally eating crickets or whatever makes sense, but we want people to choose to go to Mars. And if you make it if you're selling people that if you go to Mars you're going to be eating insects, we just don't think that that is a winning argument to make with the general public who are wanting to go. So we actually chose not to include that. The possible exception would be is we make a protein powder out of these things so that just it's not visible. You know, you don't have legs or whatnot remaining. That maybe that could be put into shake sort of thing. All right, sort of funny there. So the role of robots. Robots are a tremendous time saver, labor saver, and that's critically important, especially in the early years of a settlement. And there are increasingly sophisticated robots that are already in use in the agriculture industry. And, you know, in the next 15 years, that's just going to become all the better. So we do see robots. Now on the moon, you can have teleoperations from people on Earth 24/7. You can greatly expand the telerobotic workforce on the moon by having robots harvesting the metals and producing more robot parts, the gross parts, and then just shipping the electronics. So there could be the ratio between people to robots could be very high in favor of robots. On Mars, you got to have automated systems. Probably in 10 years from now, whenever we get this permanent base on Mars, I think the technology could be to the point where a lot of picking and planting and stuff like this could be done by automated robotic systems. Produce processing machines. Now this is like taking waste and processing it, or taking things like grains and making ingredients out of it, such as flour. Big time saver. Absolutely almost everything that we can do in that realm, we will want to do in that realm. And then storage, you got to take this into account. There's dry storage, refrigerated storage, frozen storage. That's going to be important. We don't want to be excessive in our storage unless we are preparing for the next phase of settlers, and so they have a lot of food. But we don't want to be taking up a lot of space and having to produce a lot of this sort of stuff or shipping this stuff just so we can have large quantities of storage. We want enough to be able to survive long enough for resupply, but we don't want to get too far out there. So let's get into the work of the food working group. We pulled them together. It starts with the nutritional needs, and what we decided was just take the standard recommendations for nutrition. Probably people on the moon and Mars are going to need different nutritional needs, but we're not real knowledgeable in our belief right now is that it's not dramatically different than what's required on Earth. So what you do is you work backwards. You start with the nutritional needs and you say, okay, how can we meet those nutritional needs? This is where that Mars Cookbook comes in, and that is to have recipes that only use the growable plants, and then using those recipes in a particular combination and order to be able to meet the nutritional needs of the crew. How do you get the recipes? Well, ingredients coming together make the recipes. How do you get the ingredients? Through harvest and processing, and storage. I should also add there. Well, how do you figure out when they are going to come to harvest to minimize the amount that you're storing? Well, you need a planting schedule, but that you just work back into how long does it take for a strawberry to mature from being planted. And so you can work backwards to be able to figure out, how to work forwards. Special meals, don't have pictures of this, but things like Thanksgiving and Christmas and special treats and things like this can really make the morale of the crew really help a lot. And also, as people on Earth are watching probably through television, once a week, seeing the latest things that are happening on Mars, especially with that initial permanent crew, then these special meals would be a nice sort of celebrations throughout the year. Not just American, but international holidays in their special meals as well, as represented through the initial crew, whatever ethnic or national background they come from. Oh, I guess I do have pictures of things. Oh, I love this. Domino's Pizza. Could they actually deliver? For the moon, they could. I think they might be able to deliver to Mars. So that'd be funny. And then the culinary arts, presentation can make such a big difference. And yeah, why not? And then cooking classes from Mars, I think, would be a big hit with people who are into that sort of thing. And then I did mention about the Martian Cookbook. Would love to have somebody who has an interest in this area go ahead and step forward and help us produce that. And then reducing food prep time. I mentioned everything, food processors and all these things, as well as there are cooking robots. They're very expensive, but in this setting, the expense doesn't really matter so much. The savings of labor is gonna pay for it. So there are actually robotic systems that I think we could employ in that setting. And cleanup, we are getting that obviously on the moon. Telerobots can do that. When the crew goes to sleep, they can be working to clean things up. On Mars, automated systems is a possible application for these robots. So that concludes my presentation. I really look forward to your questions. I imagine some of you probably disagree with some of the decisions we made, and that's fine. I just want to encourage you to let's engage in the dialogue.
Okay, yeah, so the first question here is, have you tested material to withstand micrometeoroids that come in at a higher rate due to less dense atmosphere?
No, but if you understand the prevalence, the frequency and prevalence of meteorites that would survive the Martian atmosphere, they're so rare that statistically I'm not terribly concerned about that. As an example, Echo 1 and 2 were some of the initial satellites put up in Earth orbits. These were inflatables. They lasted for many years without ever being punctured, despite being outside the atmosphere and with half the sky visible to even micrometeorites. So I'm just not concerned about that, actually.
Okay, then do you see a way to commercialize this so that you can work on iterations?
I am actually, I think that's a possibility, but for my time and for the time pressure that Starship is placing on all of us, I don't think the Green Hab going through a entrepreneurial sort of a process, taking years and having to get funding and convince investors is the right way. I think the right way is actually philanthropic, and I'm actively writing the proposal to get full funding for the whole InstaBase project, including the Green Hab. We'll see if it gets funded, but space projects have been funded to philanthropic space projects have been funded to a very high level, and so there's hope. And
then, do you recommend cassava for food?
Absolutely, absolutely. That's a great that's a great ingredient. Yeah.
And then another question: cleanup by sandblasting rather than water, perhaps?
To save water? Clean up.
Yep.
Is that cleanup of dishes? I just think waters probably would work best. We got plenty of water if you're on Mars.
And then wouldn't it be more advantageous to produce hydroponics underground?
So you do have the shielding, but you do have to dig the trench probably, unless you're in a crater, in which case you got to smooth the floor and then push the regolith on top. Or if you're talking about the lava tubes. So on Mars, that's possible. On the moon, it's a bad idea because they're not located where they need to be, which is at the poles. On Mars, I think that if you can find a lava tube where there's ice, I think that might be doable.
Now, what about algae and mushrooms for food?
Both are great. Mushrooms are absolutely wonderful because they can process your waste. And I apologize, I just simply forgot to include the waste processing. We would do bioreactors and incineration of whatever remains after that. But absolutely, part of that process would be growing mushrooms, and that's just a wonderful source of protein. And then what was the other one? Algae.
Oh yes.
So algae is a real possibility because it's minimal waste, and yet you've got it's fairly efficient. But as an ingredient, it's an unusual ingredient. We'd still probably use it, but limited probably.
And then what about pets for mental health?
I don't know what that has to do with green habit. You bet. I mean, come on, look at the picture.
Yeah.
I'm a pet lover. Let's bring him. Absolutely.
Yep, and that's all for the questions then.
All right. I think our timing is perfect. Please check out the website, developspace.info. Join the Space Development Network if you're so inclined.
Okay, yeah, thank you.